Okay, then we're going to look at 4.2, adding and subtracting polynomials. Basically, we have something. Let's go back. Another way to see combining like terms. Let's make that one a minus. So you want to put together the ones that are the same. And there's a few ways you could do it. You could write it by putting together. You can do it mentally. You could, if you want to, see that we've got X's and we've got Y's. So you could line them up going this way. But either way, they're both going to get us the same. What's 2 plus 5? So we would have 7 X's. And over here we'd have 3 minus 2, which is positive 1Y or positive Y. So we could have done the same thing here by going vertically. 2 plus 5 is 7x. 3 minus 2 gives us positive y. So we get the same result. So obviously we're going to throw in, yesterday we worked on exponents, so we're going to have some exponents involved in there as well. So an example. They will not always be in the order we wish, but really what we are looking for are ones that have the same variable and the same power. So these two are both cubed. These two are both squared, and then this is going to be by itself because that's all it has. So if we look at our cubes, we have -6. You don't have to always rewrite it. I like to sometimes just to make it a little bit easier to see what's going together. -6 and +6. How many x cubes would we end up with? So 6 minus 6 gives us 0. We could write 0x cubed, but we would prefer not to because we have nothing there. So we have 3x squared and 1x squared, so that gives us 4x squared. And then this is by itself, so we have 4x squared minus 5. So we're putting together the like terms. One of the biggest things that's going to happen on this assignment is our integers have to be correct, or we're going to have issues with the addition or subtraction. Now we're going to add in 2 variables. And the instructions say add. So on this, we're going to add them so we could, again, go back to finding the ones that are the same. This one is x squared y. We have x squared y, so I'm going to put it underneath. We're adding. We have 3y cubed, so it's going to go under this one. And then we have -4 minus 4. So I'm going to add straight down. How many y squared, x squared y's do we have? We have 1. So 3 plus 1 gets us 4x squared y. Again, we do not change the powers. It's the same. So like if you had $1 plus $4, we don't have dollars squared. It's still just dollars. So same thing here. Our power does not change. It looks exactly the same. This one, 4x y squared plus 0 is 4x y squared. No signs, but it's positive. +3 and -2. +1 or positive y cubed. 3 minus 4, -1. Personally, I like the vertical method where you line them up and then you just have an addition or subtraction problem. It's easier to see your signs and go straight from there. The a little bit more challenging ones come when it's subtraction. Let's do a basic one to start. Remember, we're going to subtract. So I'm going to do it vertically again. But this time, the different part is in order to subtract, we want to change every sign on the bottom. So to change each sign, our positive is going to become a negative, our negative is going to become positive. The reason we did that, let's look at it. If we had 2x plus 4y, between this negative and the parentheses is like a 1. So if we distribute, we get negative, that should be negative. Negative times 2x gets us negative 2x. Negative times negative gets us positive 4y. So we're basically distributing is why we change each sign, so that each of them makes us subtract. What is 3x minus 2x? 1x, y plus 4y, 5y, and it's positive. So let's take one like that that's a little bit more involved. So this one, negative a squared minus 5ab plus 4b squared minus 2. It says subtract from so we want to subtract this from this polynomial over here. So if we say subtract 2 from 7, how would we write that? 7 minus 2. So the last one needs to be the one on top. So we would have 3a squared minus 2ab, 2b squared minus 7. So now, have I made it a subtraction problem yet? No. In order to make it a subtraction problem, so basically we have that. So in order to do this, we need to change each of these signs to the opposite. Now we've made it a subtraction. It kind of goes back to if we had this problem, how did we work these? We changed the last two signs. So we changed that to a plus, which basically we did, and then this would become a negative. So we made it the opposite signs. Now, just like in integers, it's an addition problem. So 3a squared plus 1a squared is 4a squared. Negative 2 and positive 5. Positive 3ab. Negative 2 and negative 4. Negative 6b squared. Negative 7 and positive 2. Negative 5. And then none of these are the same, so we would stop there. Our answers are going to be longer today, but we've taken two parts and made them into one. Right? So if these are not exactly the same, like even coming back, we had an example earlier where I think it was like this. These both have x's and y's, and we've got squares, but the squares are in different places, so we cannot put those together. They have to be exactly the same. Okay. So again, the biggest key for today is lining things up, keeping your integers straight. So I want to do 148, 49. So 1 to 19 odd and 31 to 45 odd. So some addition, some subtraction. Line them up, keep your negatives and positives, remember your rules, or that's where we're going to make mistakes.